friends, welcome back to Wisdom Academy YouTube channel. This is Nilesh, and in the previous class we have learned about basic properties of charges. Today our topic of discussion will be Coulombs Law. Whenever I talk about Coulombs Law, I get reminded of Newton's law of gravitation. If you recall what you learned in Newton's law of gravitation in class 11th, you would have learned that force of attraction between any two objects is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Same way, in Coulombs law, think instead of mass, replace that mass by using charge. So what I'll do, I'll take two charges. Let that be Q1, Q2. They may be like charge or unlike charge. If they are like charges, definitely they will repel each other. If they are unlike charges, they'll attract each other. So let me take both the cases and show you. Here I am assuming Q1 to be positive and Q2 to be negative. In this case, both I am assuming to be positive. So if they are unlike charges, they will be attracted towards each other by some force. So as per Coulomb's statement, Coulomb said that this force of attraction or repulsion will be directly proportional to the product of their charges. He also said that this force of attraction or repulsion will be inversely proportional to the square of distance between them. That means from their center to center distance, the distance between them is assumed to be r. When I combine these two, I get F is proportional to Q1, Q2 by R square. To remove proportionality, I have to add a constant. That constant was added as K, Q1, Q2 by R square, where K is called as constant of proportionality. Constant of proportionality. And the value of K is 9 into 10 to the power 9. Units we can write. If you write K here, this will become Newton meter square per Coulomb square. Newton meter square Coulomb power minus 2. This K, if I go in detail, this K is equal to 1 by 4 pi epsilon naught, which is epsilon naught is called as permittivity of free space. Permittivity of free space. I mean to say that the value of K depends upon which medium they are kept. The value of epsilon naught is 8.85 into 10 to the power minus 12. So what will be its unit? You can put the value here and you can check. It would be Coulomb square meter power minus 2 Newton power minus 1. This is about Coulomb's law. So Coulomb's law says that force of attraction or repulsion between any two charges is directly proportional to the product of their charges and is inversely proportional to the square of distance between them. Mathematically, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. We are well aware that force is a vector quantity. Just now what we derived Coulomb's law, there we do not use the vector quantities. That was general expression of Coulomb's law. If we go for Coulomb's law in vector form, we should also consider the vector quantities. So let us take the same two charges Q1, Q2 being positive, they will repel each other. Then now I am writing the force and distance in terms of vector quantity. So F12 is the force on charge 1 due to charge 2. Same way, here I will write F21. It means force on charge 2 due to presence of charge 1. I can also write R12 cap as the direction vector. It says that direction of unit vector along from 1 to 2. Same way, on this I can write R21 cap as the direction vector, which says that this force is acting on this line and the distance is from 2 towards 1. Now if I write the vector, Coulombs law in the vector form, how I will write? I will write F12 is equal to K Q1 Q2 by R square. F12 I should write R12 cap. And for F21 I will write F21 vector is equal to K Q1 Q2 by R square R21 cap, where R12 and R21 are the unit vectors showing the direction of F12 and F21. Since R12 is negative of R21, I am getting one additional information about this Coulombs law, that F12 is equal to minus of F21. So this is the reason why we need to know Coulombs law also in vector form, because it gives us some additional information which we may not get by normal Coulombs law. If we talk about the limitations of Coulombs law, the first limitation can be it is applicable only to the charges at rest. So if the charges are in motion, Coulombs law is not valid. Second limitation can be this Coulombs law is applicable only to the point charges. So if the charges are not point charges, we cannot apply Coulombs law. And the third and the most important limitation is that it is applicable only if the distance between the two charges is more than the nuclear size. If you remember the nuclear size, it was less than 10 to the power minus 15 meter. So if you recall your 11th, you will remember that if the distance between two charges is less than 10 to the power minus 15 meter, then they will be acted upon by a strong nuclear force. This strong nuclear force will be much greater than the electrostatic force, and their electrostatic force is not much valid. It's very less. So we cannot apply Coulombs law if the distance between the two charges is less than 10 to the power minus 15 meters. So for applying Coulombs law, the distance between the two charges must be greater than the nuclear size. Fine. After all these things, let us come to the next topic, which is dielectric constant. It is also known as relative permittivity. It is also known as relative permittivity. Let us learn about this. What is dielectric constant? So just now we have learned about the Coulombs law. Let us apply Coulombs law to the two charges which are kept in vacuum. So what is the Coulombs force between them? It is 1 by 4 pi epsilon naught Q1 Q2 by R square. These two charges Q1 and Q2 are kept in vacuum, and then the force has been found between them, which has come to be 1 by 4 pi epsilon naught Q1 Q2 by R square. Now what I am going to do, these two charges I am going to keep in some medium. Medium can be anything. It can be water, alcohol, anything. So I am keeping the charges in some medium, and then I am trying to find what is the force between them, force of attraction or repulsion between them. That will be equal to 1 by 4 pi epsilon Q1 Q2 by R square. Why I am writing epsilon? This is the permittivity of medium. Whereas epsilon naught was, I just told before some time, it was permittivity of free space. When I find the ratio of these two, that is, when I find F vacuum by F medium, what I get? Let us try to find out. That I will get 1 by 4 pi epsilon naught Q1 Q2 by R square by 1 by 4 pi epsilon Q1 Q2 by R square. Everything gets cancelled except the epsilon naught and epsilon term. So I get F vacuum by F medium is equal to epsilon by epsilon naught. This ratio of epsilon by epsilon naught is known as epsilon R, which is called as relative permittivity. It is also known as dielectric constant. Relative permittivity, or also called as dielectric constant. So from here I can get epsilon R is equal to epsilon by epsilon naught. It is a very important relation which will be very useful for your examination. There can be one word questions from there. There can be even numericals based upon this. It is a very, very important concept. Suppose they ask you define dielectric constant, or they ask you define relative permittivity. How to define? You should not define in terms of epsilon and epsilon naught. You should define the definition of relative permittivity always in terms of F vacuum and F medium. And what is that? You can define the relative permittivity as it is the ratio of the force between the two charges when they are kept in vacuum to when they are kept in some medium at the same distance. So these two charges, the distance between them should not be changed. So when these two charges are kept in vacuum to when they are kept in free space, what is the force in both the cases? If we find the ratio between them, we get epsilon r. This is about relative permittivity. So now let us see one question. The question is, a pith ball, which is free pith ball of 5 gram carrying a charge of 10 into 10 to the power minus 9 coulomb is placed over another pith ball placed 5 centimeter below the first one. What must be the charge on the second ball such that first one remains stationary? If I draw the whole thing into a diagram, the question is being asked like there are two pith balls. Let me name it as ball B and ball A. If some of you are thinking what is a pith ball? Pith ball is a lightweight ball used for doing Coulomb's experiment. It will have a great affinity towards charge. So it will immediately get repel or attract towards the charge. That is the pith ball. So the pith ball A and B are placed in such a way that the distance between them is 5 centimeter. If I count SI unit, that is equal to 0.05 meter. And I have said that pith ball A, its mass is 5 gram. It carries a charge of, so charge carried by this pith ball A, I will say QA, is 10 into 10 to the power minus 9 coulomb. Now what they are asking, what must be the charge on the second ball such that the first one remains stationary? So you must understand that they are asking A ball should not move. Definitely one thing is very sure, if this is a positive charge, the charge of pith ball B also must be positive, because if the charge of pith ball B would have been negative, it will be attracted towards it. It won't remain away from it. So since it is remaining away from it in a stationary position, one thing we must conclude that whatever charge is there on pith ball B is a positive charge. Now we have to find the magnitude of it. Since they have used the word remains stationary, it gives us an idea that the charge, the total net force of A is in equilibrium. What I mean to say, see, they both are positive in nature, it will get repelled. Let me name that force as F, Coulomb's force. At the same time, this ball A will also have mg. This mg and F must be equal. That's the reason ball A isn't stationary. If the force F and mg would have not been equal, then this ball either would have gone above or would have come down. So for the ball A to be stationary, the condition is for ball B to be stationary, I can write very well that F is equal to mg. Now what is F? Electrostatic force. What is the value of that? I can write it as K QA QB by R square is equal to mass into acceleration due to gravity. Now see, K value is known to us, that is 9 into 10 to the power 9. What about QA is known to us, 10 into 10 to the power minus 9. What is QB that we want to find? Divided by R is known to us, it is 0.05 the whole square. Mass of ball is known to us, it is 5 gram. I can write 5 into 10 to the power minus 3 in terms of kg, and G is known to us, it is 9.81. So this equation, when you solve, you will get the value of QB, and QB will be equal to 5 into 10 to the power minus 3 into 9.81 into 0.05 whole square divided by 9 into 10 to the power 9 into 10 to the power minus 9. So when you solve this expression, I am not going to solve it for you, you must do by yourself. Solve this expression, and whatever answer you get, that must be the charge on pitch ball B for the whole system to be in equilibrium. That means ball A will remain stationary. Let us see the next example. This example says that two identical charges Q each are kept at a distance R from each other. A third charge, small q, is placed between these two charges in such a way that the three charges are in equilibrium. What is the position and the magnitude of charge small q? If I draw this into a diagram, they are saying that there are two identical charges. Let me name it as capital Q. They are kept at a distance R from each other. So distance between them is R. A third charge is placed between these two charges in such a way. So a third charge is placed between them. Let me assume it is placed here. It is not necessary that it is at a center. It may be anywhere between them. Let me assume from the first charge it is at a distance x. Right? Now they are asking, but one condition they are giving is all the three charges are in equilibrium, which will give us an idea how to proceed in this question. They are asking you to find what is the position and the magnitude of this small charge q. So what we can do, since they have told that all the three charges are in equilibrium, one thing is very sure, whatever are the forces acting on all these charges are same. So they are in equilibrium. So the net force, like if I say between these two forces, if there is a force of attraction or repulsion, that must be equal to these two forces. Only then this can be in equilibrium. Or else if this force would have been high or this force would have been high, the charge would have moved that side. For the charge to be in equilibrium, for Q to be in equilibrium, I can very conveniently say that F, or if I write like this, if I write like position A, position B and position C, then I'll write FAB must be equal to FBC. The force between A and B and the force between B and C must be equal. So when I put this condition, what is FAB? That will be equal to K capital Q into small q by x square. And what will be FBC? That will be K capital Q small q by, if this is R, this is x, this will be R minus x. So I can write R minus x the whole square. These two will get cancelled, and from here I can get R minus x the whole square is equal to x square. Square gets cancelled, and from here I can get R is equal to x by 2. Can I write like this? No, it would be R is equal to 2x. So I'll get x is equal to R by 2. Sorry. So I'll be getting x is equal to R by 2. So now I got a distance x as R by 2. See, it is a mere chance that it came in the center. Not necessarily in all the questions and all the conditions it would be in center. Here in the case of symmetry, so we can say that we got the value of small q at a distance of R by 2 from the charges. So now we have got to know its position. So we can say the position of charge at B is R by 2 from A. Second thing is, what is the magnitude of charge? That we can find by considering the force. See, there will be a force between this q and this q. It can be repulsive attractive. There will be a force between this q and this q, or this q and this q. That force also will be equal. So I can take that condition. Since FAC is equal to FAB, also it will be equal to FBC. Why am I doing this? Since all the charges are in equilibrium. Right? So now let us put what is the value of FAC? It is K Q by R square. What is FAB? K Q small q by R by 2 the whole square. What gets cancelled? Let's see. KQ gets cancelled, and I get from this thing something like Q by R square is equal to, here I will get small q by R square, this 4 goes above. Again r square got cancelled. So I can write very conveniently small q is equal to capital Q by 4. That is, the charge at B is Q by 4. So this gave me the position and this gave me the magnitude of charge Q. So in today's class, what we learned? We learned about Coulombs Law. We learned Coulombs Law in general form. We also learned about Coulombs Law in vector form. We learned the limitations of Coulombs Law. Then we came to dielectric constant, that is relative permittivity. We saw what is that. I defined what is the dielectric constant. Then we saw some numericals based upon whatever we have learned. I expect you to solve all the questions of NCERT, examples as well as the exercise question. Next class, we will start the next topic, that is about the electric field. Thank you.